In section 6.2, we're going to learn how to factor trinomials, and they're going to be in the form of x squared plus bx plus c. You will also see it written as ax squared plus bx plus c. I like that. It's in alphabetical order. Anyway, and so right now it's going to start out as a three-term polynomial, but what we're going to end up with are two binomials. So how does that happen? How do you go from ax squared plus bx plus c? Um, how do you go from that trinomial and into having these two binomials saying something times something? There's a method that we're going to use, and it's really not bad at all. It is really summed up in this sentence right here. And let me highlight the main point, okay? It's saying two integers whose product is c and whose sum is b, okay? But really, we're looking for two numbers that multiply to give us the number on the end, that multiply to give us c, and add to give us b. So let's practice a few. So I'll work these out the same way every single time. And some of the steps I take, they're a little bit nitpicky, but the consistency is key. So this is part of the consistency. I'll write out a statement, or maybe just write the word m, that I'm looking for things that multiply to give me 56, but that also add to give me 15. And where am I coming up with these numbers? Well, the sentence that we read earlier said two things that multiply to give us c, but add to give us b. So since you're multiplying to get a positive 56, that means your signs are the same. They're either both positive or both negative if you're multiplying to get a positive 56, okay? But since the two things that you're multiplying to get a positive 56 also have to add to give you a positive number, then both of your signs are going to be positive instead of them both being negative. So I'm going to write the factors of 56. So the way I got this list of factors, I mean, sometimes I can do it in my head, and then sometimes the number, let's say it's a number bigger than 56, I just go through the list of 1, 2, 3, 4, 5 in the calculator. I say 56 divided by 1, 56, 56 divided by 2, 28, 56 divided by 3. 3 didn't go into it, so I didn't write it. 56 divided by 4. 5 didn't go into it. 6 didn't go into it. 7 did. Okay? And then basically, when can you stop this cycle of writing down all these factors? Whenever you start repeating. See, 7 and 8, and then 8 and 7, I started repeating factors. So then I can stop. Now, here's the other thing. Sometimes, and you will get so good that you don't have to write all these factors out every single time. You may be able to look and say, oh, 56, well, 8 and 7 multiplied to give me 56, and they had to give me 15. So you may eventually get to where you don't have to write that out. But you already heard me say it. 8 and 7, they meet both those criteria of multiplying to give you 56 and adding to give you 15. So our answer, x plus 8 and x plus 7, could also be written as x plus 7 times x plus 8. Now, the really interesting thing about this, I mean, these both are the answer, okay? You can check your answer by distributing these We're pulling these back out. And it should give you what you began with. X times x is x squared. X times 8 is 8x. 7x. Combining my like terms there in the middle. And since I got what I started with, x squared plus 15x plus 56, I know that the factors that I chose were correct. Let's try another one. We're multiplying to get a 32, a positive 32, and we're adding to get a negative 12. Well, if we're multiplying to get a positive, our signs must be the same, as in a positive times a positive gives you a positive, and a negative times negative gives you positive. Like -1 times -1, it's +1. Okay, but of the two options that I just wrote down, which will it be? Well, you're multiplying to get that positive 32, but you're adding to get a negative 12. So since you're adding these two signs together that are the same, and you get a negative, well, then both the signs that you added together must have been a negative. I'm going to write down the factors of 32. And you can, again, use your calculator for this, but you don't have to. 1 times 32. 32 divided by 2. 32 divided by 3. 3 doesn't go into it. Divided by 4. 8 times. 5 doesn't go into it. 6 doesn't go into it. 7 doesn't. 8 goes into it 4 times. I started repeating. I can stop. Okay? So, let's go through. We know both of our signs are going to be negative. So let's make all these signs negative. And is there anything that adds to give me negative 12? -1 and -32 would be -33. This would be -18, -12, and -12 here on the end. So either -4 and -8 or -8 and -4. It doesn't matter the order that we write them in, as long as they have the right sign with them. And you can go back through and double check this by pulling those two binomials back out to see if you get the same answer. So I'm continuing writing my statement. We're multiplying to get -40 and adding to get the middle of +3. Well, think with me for a second. If you're multiplying two things together to get a -40 in this case, are your signs the same, as in both positive or both negative? Or are they different? They're different. If you're multiplying and you get a negative number as your answer, then you must have multiplied different signs. So let's take this a step further and think about, we're multiplying to get a -40, but we're adding to get a positive number, a +3. So of the two numbers that I choose, the larger number will have the positive sign with it. The smaller number will have the negative sign with it. And I always do go through and circle which one, I always circle the sign that the largest number will have. So let's write the factors of 40. We got 1 and 40. 40 divided by 2 is 20. 3 doesn't go into it. 4 goes into it 10 times. 5 and 8. 6 doesn't. 7 doesn't. 8 goes into it 5 times. And look back up here. I said I always circle the sign that will be with the largest number. So if the largest number is going to be positive, that means the smaller number will be negative. So let me go through and make these smaller numbers negative. And let's see if anything fits the criteria. If it doesn't fit the criteria of multiplying to giving negative 40 and adding to give me positive 3, if nothing fits that criteria, I can't make it happen. If nothing fits that criteria, it would be prime. But let's see. Negative 1 and 40 would give me negative 39. Excuse me, positive 39. $18, 6, and 3. Same with this as well. So, y plus 8, y minus 5, or y minus 5 times y plus 8. Order doesn't matter as long as you keep the right sign with the right number. On this one, we're multiplying to get a negative 7. We're adding to get a positive 6. So if we're multiplying to get a negative number, our signs are different. And since we're adding to get a positive 6, the larger sign will be positive, the smaller will be negative. So the factors of 7, just 1 and 7, 7 and 1. The larger number would be positive, the smaller number would be negative. And yes, that does add to give me positive 6, negative 1, and positive 7. So we can write it as c plus 7 and c minus 1. On this one right here, we must have a typo. I think those variables were supposed to be the same. Let's just call that y squared plus 14y plus 49. So that means we're multiplying to get 49. We're adding to get 14. Since we're multiplying to get a positive, our signs are the same, either both positive or both negative. But you're adding the two same signs together to get a positive 14, so they must both be positive. So the factors of 49, I believe, are 1 and 49, 7 and 7. We're repeating, we can stop. And 7 and 7, they multiply to give you 49, they had to give you 14. So you can write that as y plus 7 times y plus 7. This is the correct answer, but you could go a step further and write this as y plus 7 squared. And the reason I can do that is because when you multiply something by itself, you're squaring it. Well, I multiplied y plus 7 by itself, so that's y plus 7 squared. On this one, we're multiplying to get a positive number, meaning our signs have to be the same. Either both positive or both negative. And we are adding to get a negative number. So they would both have to be negative if they're going to be the same sign, but yet you're adding to get a negative number. So let's write the factors of 4 really quickly. You got 1 and 4 and 2 and 2. And we found out that both signs have to be negative. Well, negative 1 and negative 4 add to give me negative 5. Negative 2 and negative 2 add to give me negative 4, but that's not what I needed. I needed negative 3. So I wrote all the factors of 4 down, but none of them added to give me a negative 3. So I can't make it work. That just means it's prime. It doesn't factor. On exercises 7 and 8, it's really a multiple choice, and it's wanting us to pick the correct combination. So on on 7 right here, let's write that statement. You're multiplying, and it's kind of weird because we don't have any numbers, but you're multiplying to get a positive C, and you're adding to get a negative B. Well, if you're multiplying to get a positive, your signs have to be the same, right? So either both positive or both negative. And since you're adding to get a negative, well, then they can't both be positive. They'll have to both be negative. So option C is our answer there. Okay, and then on 8, you're multiplying to get negative C. You're adding to get B. If you're multiplying to get a negative, your signs are different. But you're adding these two different signs to get a positive B, so that must mean your larger number is positive, your smaller is negative. B, option B would be the best option there. Some important things to remember when factoring. You do want to make sure that your trinomial is in order, in descending order of x squared plus bx plus c. As in, if it were 2x plus 3 plus x squared, you would want to rewrite that as x squared plus 2x plus 3. Okay, so that's what it's meaning about being in descending order. And then the next thing to remember, it doesn't matter what you're factoring, you always need to look for a GCF first. Okay, and that's what this sentence is saying. Always look for a GCF first. If there's a GCF, factor it out. There's not always one, but sometimes there will be. And even on those factoring by grouping problems that we did, we needed to have looked for a GCF first. In the last lesson when we did factoring by grouping, and sometimes there was one. Anyway, so always look for your GCF first, and then you can move forward with whatever method you are using. So I'm glad that I pointed that out, because this one is not in descending order. I'm going to write it in descending order. And now I'm going to write my statement. We're multiplying to get negative 20. We're adding to get a positive 8. So if you're multiplying to get a negative, your signs are different. And you're adding to get a positive. So your larger number will be positive from that list of factors. So 20. 1 and 20. 2 and 10. 3 doesn't go into it. 4 and 5. 5 and 4. And our largest number is going to be positive. That means the smaller will be negative. So let's go through and make the smaller ones negative and see if anything adds to give me positive 8 and the negative 2 and the positive 10 do. And do remember, you can check these answers by foiling these binomials back out, and you should get what you started out with, x squared plus 8x minus 20. So one of the criteria it taught us to look out for was make sure it's in descending order. We also talked about how you always have to look for a GCF first. And so this one is in order. It is in descending order. Is there a GCF? 3b squared, 9b, 6b. I can't pull out a b because 6 doesn't have a b. But all three of those numbers, 3 goes into all of them. So if I pull 3 out, I'm left with b squared minus 3b plus 2. How did I end up with that? Well, I divided everything by 3. So now the 3 is factored out, and I'm just going to worry about factoring the trinomial behind that, the b squared minus 3b plus 2. Okay, so that GCF, it just goes in the front. I don't worry about it anymore, except for making sure I write it down in my final answer. Anyway, my statement, I'm multiplying. Be careful here. I'm multiplying to get not 6, because remember, I changed the problem. I factored out a 3. So now I'm multiplying to get 2, and I am adding to get negative 3. So since you're multiplying to get a positive number, your signs are the same. But since you're adding those two same signs together to get a negative, they must both be negative. So the factors of 2 are 2 and 1 and 1 and 2. And if I make them negative, they add to give me negative 3. On number 11, is it in descending order? Yes, you have that x cubed in front, and then it goes to squared, and then x to the first power, so it's in descending order. Is there a GCF? 4, 8, and 60. Well, you can take out a 4, and then every term also has an x, so take out your lowest power of x. So if you divide everything by 4x, 4x cubed divided by 4x is just 1 x to the first, excuse me, not x to the first, but x squared. I got the x squared by keeping the base and subtracting the exponents. Minus 2x minus 15. So now, for my statement, I'm multiplying to get negative 15. I'm adding to get negative 2. Well, if you're multiplying to get a negative, your signs are different. And if you're adding to get a negative, well, then your larger factor, your larger number, will be negative. So the factors of 15 are 1 and 15. 2 doesn't go into it. 3 does 5 times. 4 doesn't. 5 does 3 times. I make my larger number negative and see if anything adds to give me negative 2. And positive 3 and negative 5 add to give me negative 2. So that inside could be rewritten as x minus 5, x plus 3, and you have your GCF of 4x out there in the front. On this one, we are in descending order. There's not a GCF, but the leading coefficient is negative. I'm going to factor out a negative 1, and that just changes the sign of everything, basically. So I'm going to write my statement. You're multiplying to get a positive 16, and you're adding to get a positive 10. If you're multiplying to get a positive number, your signs are the same, and since you're adding to get a positive, they're both going to be positive. So 16, you got 1 and 16, you got 2 and 8. You know what? There are more factors of 16. I could keep on going because I haven't started repeating yet, but 2 and 8 work, right? 2 plus 8 is 10, 2 times 8 is 16. So I don't have to keep going. Not if you're comfortable stopping. Okay, on this one, are we in descending order? No, we're not. And now, is there a GCF? Yes, there is. So we're multiplying to get 6, and we're adding to get 5. And they're both positive. When you're multiplying to get a positive number, you will have the same sign, either both positive and both negative, but since you're adding to get that positive 5, they'll both be positive. The factors of 6 are 1 and 6, 2 and 3, 3 and 2. And be careful on this one. Your mind can play games with you. 1 and 6 would have to give you 7, so that's not it. It's 2 and 3. Leave that GCF in the front. This is a fun one because we're asking that question, are we in descending order and is there a GCF? First of all, I'm seeing the S in descending order from squared to the first power to no S. But I'm also seeing another variable, and it's T. It's not in descending order, right? The squared's in the back. So maybe it's a GCF. Maybe that's what goes through my head for a minute. But no, T is not a GCF because it doesn't have it right here. Notice this. This is what's happening. S is descending in power and T is ascending. Okay? So basically what that means, where we would have had S minus something and S minus something, since T is ascending in the back, basically, whatever numbers we choose, it will have a T with it, okay? So we're still multiplying to get 24. We're adding to get that middle of negative 11. You're multiplying to get a positive 24, so your signs are the same, but you're adding to get the negative. So that's why I went ahead and said S minus, S minus. 24, the factors are 1 and 24, 2 and 12, 3 and 8, and I think that works. If I made them both negative, 3 and negative 8. So basically, if this problem, and this is not the problem, but the one I'm about to write, if this problem were S squared minus 11S plus 24, the answer would be S minus 3 and S minus 8. And while this is not the problem we were given, it does look very similar to it. The only thing different is that we got that T in the back, right? The T is ascending in power, so we're going to put it in the back, and this problem will have a final answer of S minus 3T and S minus 8T. On number 15, we are in descending order. There is no GCF, but now this one is a little bit different. This wouldn't look so different if it said p squared plus 4p minus 45, right? That wouldn't look as odd. But we're starting out, instead of with a p squared, we have a p to the fourth. Let's worry about that in a second. Let's write our statement down of we're multiplying to get negative 45, and we're adding to get a positive 4. Since you're multiplying to get a negative, your signs are different. Since you're adding to get a positive 4, your larger number is positive. The factors of 45, okay, and that's it. Your larger number will be positive, meaning the smaller will be negative. So negative 5 and a positive 9. Now, again, if this was what we were dealing with, the answer would be p minus 5 and p plus 9. Notice this. You remember how I told you you can FOIL that binomial out to check to see if you got the right answer? And notice every time the two things on the end, -5 times +9, give you -45. And then p times p gives you p squared. So since our problem is not this, since our problem begins with a p to the 4th, okay, that just means instead of p minus 5 and p plus 9, our answer will be p squared minus 5. And p squared plus 9. And why is that? That's because p squared times p squared is p to the 4th. Okay, so are we in descending order? Are we in order? My rule of thumb is if you spend more than about 5 seconds trying to answer that question, move on. Okay? Now, let's also ask the question, what's the GCF? Is there a GCF? A cubed, a squared, a. We can take out a a. We can also take out a b squared. Every term has a b squared. So if I divide everything by ab squared, a cubed divided by a is a squared, and then b squared divided by b squared, just the b goes away basically in every single part of this because everything had a b squared. Okay, plus 14 a squared divided by a is a, and we got 48 on the end. So we're multiplying to get 48. We're adding to get 14. Our signs will be the same since we're multiplying to get a positive, and since we're adding to get a positive 14, they'll both be positive. So the factors of 48. We have all the factors listed here. 6 and 8, or 8 and 6 would work. So that's our final answer. And then 17 and 18. I love these questions in there because they're just good to think about. So a student gave this as their answer, okay? 3x squared plus 9, and then x minus 4. Did the instructor give, or it actually says the instructor did not give full credit. Why? This is why. Because they must, if they got this as their answer, they must not have factored out the GCF first, okay? Because whenever they factor that trinomial, one of their factors, the 3x plus 9, has a GCF. If you pull out a 3 from 3x plus 9, you're left with x plus 3. And then you're left with x minus 4. Nothing happened yet. But their answer wasn't fully factored. I mean, they factored it, but it wasn't fully factored. So they didn't pull a GCF out as their very first step. Okay, and number 18 is saying, what polynomial factors as x plus 5 and x minus 12? That's just a really weird way of saying, hey, multiply this back out to tell me what the original problem would have been. So x times x is x squared, negative 12x, positive 5x, and then negative 60 on the end. Let's combine our like terms in the middle there.